How do you choose the best pattern recognition algorithm? Imagine trying to find your favorite book in a huge library. You look for clues like the cover, the title, or the author. Choosing a pattern recognition algorithm is similar. You need to find the right fit for your data and problem. Pattern recognition helps computers identify and classify things in data, like recognizing faces or sorting emails. But how do you pick the best method? That's what we'll explore today. First, think about what kind of problem you are solving. Are you trying to predict something based on labeled data? That's called supervised learning. For example, telling if an email is spam or not. Or are you trying to find hidden groups in unlabeled data? That's unsupervised learning, like grouping customers by shopping habits. Sometimes you have a mix of both, which is semi-supervised learning. Knowing this helps narrow down your options. Next, look at your data. How much do you have? Is it simple or very complex? If your data has lots of features or dimensions, some algorithms might struggle. For example, K-nearest neighbors works well with small, simple data but can slow down with large, high-dimensional data. If your data is huge, you might need faster algorithms like support vector machines or decision trees. Also, check if your data is noisy or has missing parts. Pre-processing steps like normalizing or reducing dimensions can make a big difference. Now consider what kind of patterns you want to recognize. For images, convolutional neural networks are very effective. They can learn to spot shapes and textures. For sequences like speech or text, recurrent neural networks or transformers are better suited. If your goal is to classify data into categories, support vector machines or decision trees are good choices. For grouping data without labels, K-means clustering is often used. Feature extraction is another key step. You want to pick the most relevant parts of your data to feed into the algorithm. Good features make pattern recognition easier. Cleaning and normalizing your data also help your model learn better. This can include removing noise or balancing your dataset. Once you select an algorithm, don't forget to tune it. Adjust parameters like learning rate or regularization to improve performance. Cross-validation is a handy technique to test how well your model works on new data. It helps prevent overfitting, which is when your model learns the training data too well but performs poorly on new data. Finally, think about how much time and resources you have. Some algorithms need more processing power or longer training times. Choose one that fits your project size and deadline. Remember, there is no one-size-fits-all answer. The best pattern recognition algorithm depends on your specific problem, data, and goals. By understanding these factors, you can make a smart choice that helps your AI system work effectively.